This is part 9 of the module 7 lecture, and in this part we're going to start presenting the confidence interval estimate of the proportion, and this is corresponds to section 8.4 in the textbook. All right, I like to start with an example, and this example came from the beginning of this president's administration, where people were saying that the Affordable Care Act, or what people call Obamacare, was collapsing. And I thought it'd be interesting to see if that claim was correct. So in this Gallup Healthways Wellbeing Index reported that 10.9% of individuals 18 years and older in the U.S. by the end of the fourth quarter of 2016 were uninsured. And that's what is shown in this graph right here for the fourth quarter, and I'm showing when this Affordable Care Act was implemented, and you see the insurance went down. And these politicians were saying that this system was imploding, people were abandoning it, and so you would expect that the rate of uninsured will go up over time as time went on. All right, so a study was conducted to assess the rate of uninsured individual 18 years of age and older in the U.S. at the end of the first quarter of 2017. So the data I show you is at the end of the last quarter of 2017, and we're seeing collecting data at the end of the first quarter of 2017. So a sample of 500 individuals were randomly selected. Each individual was asked if he or she had any type of health insurance. Of these 500 individuals, 53 indicated that they do not have any type of insurance. So the question is the true rate of uninsured individuals 18 years of age and older in the U.S. at the end of the first quarter of 2017 the same as the rate reported at the end of the fourth quarter of 2016? So we want to see if that rate of uninsured is the same, or we may find that it went up, or it maybe went down. We don't know, but we're going to look at this number. All right, so the first thing is, as we've seen with this kind of problems, is do we really have a binomial experiment? So we can say that these 500 individuals were interviewed identically, so we have identical trials. We have only two outcomes: either the individual is uninsured, or the failure will be that the person is insured. And the probability of success, pi, and the probability of failure is the same for every individual that we interview. And of course, pi here is not known. We can say that the trials are independent because these individuals were selected at random and interviewed separately. And finally, the random variable counts the number of uninsured individuals. In this case, the random variable is 53. And again, I'm using these OBS for observed. So this is the observed number of successes in the sample. So OBS means it's an observed number from a sample. All right, so using this information, so 53 out of 500 said that they were not insured. So we can say, and so our point estimate of the proportion of uninsured at the end of the first quarter of 2017 is 10.6%. Now, we know from our previous discussion that if we were to take a new sample, that proportion will change. So it makes sense to supplement this point estimate with an interval estimate for the population proportion. And that's what we're going to do, because remember, this is just a point estimate of the actual population proportion, or the probability of success. And so this number will change from sample to sample. So a good idea is to supplement it with a confidence interval. All right, so the unknown parameter is the probability of success pi in the binomial probability distribution. The parameter pi is estimated by a point estimate. This is the sample proportion. And where x observed is the number of observed successes in the sample, and out of a sample of n, of size n. And so because we're using the sample proportion to estimate the population proportion, So the confidence interval need to be constructed using the sampling distribution of the proportion. So from our previous discussion from the beginning of Module 7, you might remember that the parameters of the sampling distribution of the proportion are that the mean of the sampling distribution is used the probability of success, and the standard deviation is used the square root of the probability of success times the probability of failure divided by the sample size. Well, but we have a big problem. Pi is not known. So what do we do? Well, we just replace pi by its point estimate, p. And so now that what we have are the estimates of the mean and the standard deviation of the sampling distribution of the proportion, because we're using the point estimate, the proportion. And this hat symbol in statistics means estimate. So these are the estimates of the mean and the standard deviation. So now we know we can estimate the mean and the standard deviation of the sampling distribution of the proportion. And then from the central limit theorem, we know that if the sample size times the proportion of success and the sample size times the proportion of failure, if both of those are at least 5, then we know the sampling distribution of the proportion can be approximated with a standard normal distribution. So now we have the 3 elements we need to calculate probabilities: the estimate of the mean, the estimate of the standard deviation of the sampling distribution, and that if we comply with these requirements, then the sampling distribution of the proportion is normal. All right, so using that information, using these expressions of the mean and the standard deviation, and that the fact that the sampling distribution, if we meet those conditions, is normally distributed, then we can the limits of the confidence interval can be calculated as this. So the low limit is the point estimate of the proportion minus the z-value for alpha over 2 that comes from the level of confidence times the estimate of the standard deviation of the sampling distribution of the proportion, which is the point estimate of the proportion of success minus the point estimate of the proportion of failure divided by the sample size. And again, in this, in the context of this problem, this expression right here is the margin of error, which is what I'm showing here. But notice that now we're going to use z-scores to calculate these confidence intervals. That means we need to use table 4 to find the z-value. All right, I'm going to stop here. In the next segment, we're going to discuss continue the discussion of the problem, or the example that I started with.